Hello and welcome once again to Learning Together, sponsored by the Brosis Foundation. What is the purpose of this tutorial? Our goal is to create, for math and English, resources that will be available to students all over the world, where they can, at their own leisure, check in and update their skills and even remind themselves of some of the things that they have already studied. If you have been following us for math, you will see that there are days when the material is very simple, and then there are other days when it is more demanding. Today, I'm going to shift a little bit and cater to those students who are visual. You like shapes, okay? Instead of just letters and numbers, you like to see a few shapes. So I'm going to transition a little bit just for convenience and just to change the flow and go into some shapes and explain some things related to that. So I'll start by telling you that today's topic has to do with the Pythagorean So that's where we're going today. We're going to be talking about the Pythagorean Theorem, a very, very important concept. And then we're going to also deal with the area of a triangle. This is going to segue us into an introduction to trigonometry. Yes, trigonometry. And we're going to do some fun stuff. But for today, we're going to just ease you in and transition from the more abstract stuff into some more tangible and visually appealing items. So, what is a right triangle? Well, a right triangle is a triangle that has one angle that is 90 degrees. Again, for it to be a right triangle, it must have an angle that is 90 degrees. Interestingly enough, in math world, there's a way to indicate a 90-degree angle. So whenever you see that symbol, all people in math world know that it signifies or it means 90 degrees. What is that symbol? Well, whenever you see this, it's 90 degrees. And this is a right triangle. So I'm going to take the lazy way out. Whenever you see this symbol, it is an abbreviation for triangle. So you'll see right triangle. Cut down on some of the writing. So this is the 90-degree angle right here. Okay? So of course, if this is 90 degrees, somewhere along the line, you might have picked up that the three angles of a triangle always total 180 degrees. Three angles of a triangle always have a total, the internal angles, 1, 2, 3, always become a total of 180 degrees. Interestingly enough, if I gave you a four-sided figure, a quadrilateral, if this is 180, and this is 180, then the four sides, a four-sided figure will have a total of 360 degrees. At a later date, I'm going to show you a relationship between the number of sides of the polygon and the sum of all the interior angles. We're going to get there eventually. But for now, we're going to be staying with right triangles. In math world, we have a habit of labeling the sides of a triangle. And it's a very common practice. When there's a right triangle, It's a very common practice to always label this side as C and the other two sides as A and B. Very common practice, and there's a reason for it. There's a reason for it. But before we get into the reason, I want to give you the names of the sides of a right triangle. The side that is across from the 90 degrees is called it has a name, it's called the hypotenuse. So this side, the longest side, the one facing the 90 degrees, across from the 90 degrees, is called the hypotenuse. And this side, they are called legs. So these are the legs. They come together and they form the hypotenuse on the other side. So again, the legs and the hypotenuse. And there is a very important mathematical principle that connects the legs and the hypotenuse. And that principle is called the Pythagorean Theorem. You cannot afford to forget that. It's so significant. And you must be asking, what is that theorem? What does it do? Well, the Pythagorean Theorem so I'm going to use TH as abbreviation for theorem. What it says is that if I square this leg and square that leg, the two of them added together will equal to the square of this leg. So A squared plus B squared is equal to C squared. This principle is going to come back over and over and over and over and over again. Even when you get to calculus, the Pythagorean theorem will come back into play. When you're dealing with the coordinate geometry, as in the distance between 2 points, the Pythagorean theorem is going to come into play. When we're doing equation of a circle, the Pythagorean theorem is going to come back in. So stay with me, learn this, and we're going to use it over and over and over again going forward. Okay? So what does this mean? It means that if you have a right triangle, notice now, this only works for right triangles. Notice how many times within 3 minutes I've said right triangle 1,000,000 times already. Oh, by the way, see my symbol at the back for Black History Month celebration. Just a little representation. Good. So when you have this, what it means then is that if I gave you any two sides of the triangle, you can find the third just by manipulating that equation. If you know A and you know B, you can calculate and find C. If you know C and you know B, you can solve that and find A. Similarly, if you know A and C, you can find B. So this is beautiful. It's a very excellent way. It's a very, very effective way of solving right triangles. Let me pause quickly and just share with you that there is a relationship between the sides of a triangle. The longer the side, the bigger the angle across from it. So if you look at these, if I gave you, say, for example, a right triangle, if all three angles make 180 degrees, and this is 90, then we know that this and this will total 90. So therefore, this side has to be smaller than that, and this side has to be smaller than this. So if this is, say, 60, and this is 90, then we know that this has to be 30. And what we're saying is this. If this is 60 degrees, the side across from it must be longer than the side across from the angle that's 30. So the smaller the angle, the smaller the side suspended by that angle. How can I explain that? Okay, watch this. If these are my legs for the triangle, as the angle gets bigger and bigger, the distance from my fingertips gets wider and wider. Okay? All right, this is better. There it is. These are the legs. As the angle gets bigger and bigger, the distance from my fingertip gets bigger and bigger. So that's the idea. So you should never, ever get a leg that is larger than the hypotenuse. That's a contradiction right away, and you know that something is wrong. Okay? So, now that we have laid the foundation for the Pythagorean theorem, let's go and solve some equations, or solve some triangles. Okay, so we have two questions on the board. Two questions. This one here, this is a 90-degree angle. So this is our 90-degree angle. So because it's a right triangle, we say, okay, good. If it's a right triangle, I can use the Pythagorean theorem. If it's not a right triangle, I can't use the Pythagorean theorem. Got it? Sweet. So here we go. What are we given? This 12 is a leg. This 5 is also a leg because the two legs form the 90 degrees. Two legs form the 90 degrees. And of course, the one that is missing is the hypotenuse. So according to the Pythagorean theorem, this squared plus that squared will always be equal to that squared. So we can say, okay, 12 squared plus 5 squared is equal to x squared. And then what is 12 squared? It's 144. What is 5 squared? It's 25. When we add these two together, we get 169. So therefore, x squared is equal to 169. Okay? And therefore, now we need to find what is x. So in order to find x, which is the length right here, we need to get rid of the square. And in a previous lesson, we discussed that the opposite or the inverse of square is square root. Just as the inverse of multiply is divide, the inverse of add is subtract, but the inverse of square is square root. So we know that x is going to be equal to the square root of 169. Now, I will pause right here because I always want us to connect the math from all pieces, all parts. In a previous lesson, we discussed that if you have a quadratic equation, the degree is 2. In other words, the highest exponent is 2. Then the highest exponent or the degree tells you the number of solutions. So this 2 tells me that there are 2 solutions. X squared equal to 169 means that there are 2 numbers when multiplied together, when they multiply by themselves, will give you 169. The answer would be plus or minus the square root of 169, which becomes plus or minus 13. But right away, you're going to say to me that, wait a minute, the length of the side of a triangle cannot be a negative number. So therefore, the negative solution is not practical. It's not useful, and therefore it's discarded. So the answer to this question is that we need only the positive root, okay? And just by putting it like that, we're looking for what is called the positive. You will see that symbol in math world. I just want you to know. It's the positive root only. Again, because this is a practical question, and because it's practical, it's not theoretical, the negative value of x would not have any meaning. As a matter of fact, there's a name given for this. For a solution to an equation that does not have a practical value. It's called x So it's called an extraneous solution. Listen to that word carefully, extraneous, okay? So it is a solution to the equation, but in terms of application, it's meaningless, okay? So going forward, months down the road, we will come across questions when we solve, we realize that this value is extraneous and we can eliminate or we can ignore, okay? Extraneous solutions. So what have we discovered? That x is 13. This is 5, this is 12. This has to be 13 in order for it to be a right triangle. Okay? What about this one? Okay. Maybe I could erase this so we have the space to work with. I know that there's some people are smiling because now you're seeing images and you can start being visual. You can say, okay, I can wrap my brain around this. Like last week we did, permutations, combinations, factorials. It was just a lot of numbers and you kind of get dizzy after a while. But now I see shapes. I say, I got this. So according to the Pythagorean theorem, we need to find what the legs are. Here I see that the legs are 12 and x. Remember, the legs stay together. The hypotenuse stays by itself. So the hypotenuse is always by itself. The legs are always together. They are joined together at the hip. Okay? So here we go. 12 squared plus x squared is equal to 15 squared. And I'm so glad that we spent the first few weeks solving equations. So this is an equation, and we're experts at solving equations. As a matter of fact, we even solved high-degree equations back a few weeks ago. So this is not going to phase us. This is just a quadratic equation. Big deal. We can handle this. So here we go. 12 squared is 144 plus x squared is equal to 15 squared is 225. So we need to solve, meaning we need to isolate the x. We need to get the x by itself. So we need to get rid of the 144. It's positive 144, so we need to subtract. Subtract. So now we end up with x squared equal to, subtract that, we end up with 81. So if x squared is 81, in order to get x, we need to find this positive root of 81. You will not often see the plus because most people will not put the plus, but I'm just putting the plus for emphasis so you understand that we're looking for the positive root only. And that, of course, means that x is equal to 9. Okay, pretty cool. So again, if you have a right triangle and you have any two sides, you can find the missing side. Okay? Okay. Pythagorean triples. These are three numbers that if used for the sides of a right triangle, they will work. And we're talking about whole numbers, three integers. When you put them on a triangle, the triangle will be a right triangle. There aren't many, there are only a few, okay? For example, 3, 4, and 5. That's the most popular, that's the most common. Let's check it out. Let's check it out and see if that's real. Well, 3 squared is 9. Is that equal to 5 squared? Well, 3 squared is 9. 4 squared is 16. Is that equal to 25? 9 plus 16 is 25. Yes. So 3, 4, 5 is a Pythagorean triple. The three numbers will form a right triangle. Guess what? If you multiply these by 2, you'll end up with 6, 8, and 10. So these numbers are all multiples of those numbers, the same multiple. This is double, this is double, this is double. Will they form a right triangle? Well, let's check it out. So we have 6, 8, and 10. Aren't you impressed that I'm trying to make sure that the length of my sides are proportional? If I put 6 here, it should not be longer than the side that's 8. If this is 10, it should not be shorter than the side that is 6. I'm trying to make it proportional. So let's see what happens. 6 squared plus 8 squared. What's that? 6 squared is 36. 8 squared is 64. What is 36 plus 64? That's 100. What's the square root of 100? That's 10. There it is. So we see that it works. Let's see one more time. Let's try one more. Let's multiply this by 5. 5 3s, 15. 5 4s, 20. 5 5s, 25. Oh boy, these numbers are big. Okay. Will this be a right triangle? Well, they are all multiples of this. 5 3s, 15. 5 4s, 20. 5 5s, 25. If this one works, I think it's reasonable for us to assume that any multiple of a Pythagorean triple will also form a right triangle. Okay, here we go. So let's put the legs together. So this is 15, this is 20. Is this going to be 25? Let's find out. 15 squared plus 20 squared is equal to, 15 squared is 225. 20 squared is 400. 225 plus 400 is 625. What is 25 times 25? Well, 25 times 25, 5 times 25 is 125. 2 times 25 is 50. 6, 25. Yay! It works. It works. So then you're going to say, wait a minute, are these the only triples? What we are mentioning here is that the triples, you don't have to show all the multiples. This is considered one and its multiples. Okay? So we don't have to write these. Now, suppose this was, let's get a random number, 8. And then this was, if this is 8, let's use this as 14. What is x? I am deliberately doing this so you can realize that in order for it to be a right triangle, it does not have to be an integer or a whole number. It could be a decimal. Okay, and that's okay. Let's go. Well, according to this, 8 squared, in order for it to be a right triangle, 8 squared plus 14 squared is equal to x squared. 8 squared is 64. 14 squared is 196. Add these together, we end up with 0, 6. So x squared is equal to 260. So therefore, x is going to be equal to the square root of 260, which is approximately. That is not a whole number. That is not an integer. So we're going to give an approximate result for that. So now we're doing the square root of 260. And I see here it is 16, approximately 16.1245. So if I was giving this to you as a question, I'll say round your answer to 2 decimal places. In that case, it will be 16.12. If I say round your answer to 3 decimal places, it will be 16.125. Okay? We'll talk about rounding at another date. Okay, so again, we made it clear that to form a right triangle, it does not have to be integers. However, there are certain integers we call Pythagorean triples that are actually perfect. Let's look at another one. Let's try 20, 21, and 29. Is that a triple? Will those 3 sides form a right triangle? Let's check it out. Always put, you don't even have to draw the triangle now. All you know is that the 2 smaller lengths must be on the same side, and the longer length must be by itself. So let's check. Is 20 squared plus 21 squared, is it equal to 29 squared? So let's find out. What is 20 squared? That's 400. Okay? And it's the end of the day, so my brain is saying, I don't know what that number is, so it's plus 441. Is that equal to 29 squared? And I'm going to use my calculator. You can use your calculator. 29 times 29 equal to 841. What is 400 plus 441? So therefore it checks out. So yes, that's a triple. It is a triple. So what kind of questions can you get? I'll give you an example. Determine which of the following form right triangles. And I'll give you a set. 1. Let's go with okay. So we have 3 questions. 5, 12, and 13. Will those 3 sides form a right triangle? 15, 17, and 8. 25, 24, and 7. 24, 26, and 10. So let's go. The first one. Remember, the 2 small lengths must go on the same side. So 5 squared plus 12 squared equal to 13 squared. Let's find out. 25 plus 144, is that equal to 169? Let's find out. 25 and 144, 169 equal to 169. You can say yes. Yes, it works. Now, the second one, 15, 17, 8. Now, with my slick self, I mixed the numbers up. You need to realize that the longest side must be by itself. That's the hypotenuse if it's a right triangle. So you need to put the 2 smaller sides together and keep the longest side by itself. So now we have 15 squared plus 8 squared. Is it equal to 17 squared? Well, let's find out. 15 squared is 225. 8 squared is 64. And 17 squared is actually 289. You can double check if you think I'm guessing. If you put in 17 to the power 2, what do you get? 289. There it is. So 225 plus 64, that's 289. Equal to 289. So yes, this works. Very simple. Once you understand what to do, it becomes simple. Now the next one is 25, 24, 7. So we realize that 25 has to be by itself. So we go to 24 squared plus 7 squared. Is it equal to 625? Whoa. Is it equal to 25 squared? My brain just went fast. I do not know 24 squared. So let's try it. 24 to the power 2. According to this, it says 576. And that's 49. Is equal to 625. That one I do know. So 576 plus 49. What's that equal to? Wow. 576 plus 49. Guess what? That's 625. What? So this is also a Pythagorean triple. Okay? And then if you look at the last one, you should see that 24 is 2 times 12. 26 is 2 times 13. 10 is 2 times 5. So this is a multiple of number 1. So if it is a multiple of number 1, we already understood that it would work. Okay? So what happened if I gave you this one? 12, 16, and 25. 12, 16, and 25. Do those three sides form a right triangle? Well, let's check it out. 12 squared plus 16 squared is equal to 25 squared. We go 12 squared is 144, plus 16 squared is 256, 25 squared is 625. 144 plus 256, that's 0, that's 0, that's 400. Is 400 equal to 625? The answer is no, it's not. So therefore, it does not form a right triangle. Not complicated, very, very simple. Okay? Not very, very simple, but once you know it, it becomes easy. But you have to know the principle. So what I'm going to do now is that I'm going to list the Pythagorean triples, the common Pythagorean triples. There are about 1, 2, 3, 4, 5. I'm going to list the first 5, and then we'll leave it right there. So, common so definitely, this is the first one. It's 3, 4, and 5. That's the most common one, 3, 4, 5. Next one is 5, 12, and 13. Next one is 8, 15, and 17. The next one is 7. That's ugly. 7, 24, and 25. And finally, this one is 20, 21, and 29. Those are very common, especially these first two. These first two are used a lot, okay? And if you can spot this, it can save you a lot of time when you're doing timed assessments. Okay, so now we're finished with the Pythagorean Theorem and also Pythagorean Triples. Just want to spend some time on right triangles. And we're doing great with time, we're doing excellent. So now you have this as part of your record. Let's go to the area of a right triangle. Okay, so if we go, remember, it has to be a right triangle, okay? So, if this is A, and this is B, actually, I like to use, this is the height, and this is the base. Okay, so the area is equal to a half base times height. What does that mean? The area is obtained by finding the the two legs and multiplying the two legs and dividing by 2. If you look at this, you'll see something. There's a sidebar. Look at this. Many of us know that if you have a rectangle, the area is length times width. Length times width. Now, this is a right angle. If you draw a diagonal, what does this do? This cuts the rectangle into 2 equal halves. Okay? So this is also W, this is also L. Don't you see that these two form the legs and the diagonal is the hypotenuse? So if the four-sided figure, the rectangle, is length times width, then the triangle, half of that must be a half the length times the width. Of course, because it's a triangle, its base and the height. So let's apply that and see if we could play some games with that. Okay, again, this principle can be used if you have a right triangle. If you do not know the height, then you cannot find the area. Okay, so it's important that you're able to find the height of the triangle. Without the height, you're not going to be able to find the right triangle using this principle. There's another principle that we will learn, but that's for another time. Okay, that's when we start to do trigonometry, then I'll teach you that other method. Okay? Okay. Okay, here we go. We'll find this one first, and then we'll tackle that one over there. Okay? So, what is the area of this triangle? Well, this is a leg, this is your height, this is your base. Of course, this is the hypotenuse. So you have the two legs. Those are what you use when you have the triangle like this. So the area equal to a half base times height is equal to a half 16 centimeters times 9 centimeters is equal to a half times 16 is 8. 8 times 9 is 72. And of course, the length is in centimeters, and you have length times length, centimeters times centimeters. The unit for the area becomes centimeters squared. Or you could say square centimeters, but centimeters squared or square centimeters. You will see square yards or yard square, square feet or feet squared, square inches, etc. Okay? So this will be the answer for the first one. Again, in this case, it was straightforward. You have the height and the height and the base given to you. So it was no big deal. However, sometimes it's not as straightforward. Sometimes you might have to do a little juggling first before you can get to your destination. So let's look at number 2. In number 2, you're given the hypotenuse and you're given one of the legs. So we need to find the other leg before we can find the area. So even though they say find the area, in order to do that, you have to do a little work first. You have to do a little prep. before you can deliver. So let's go and find, let's call this x. So we have to find x first, and then once we have found x, then we can deliver. By the way, trivia, that is the flag of which country? Extra credit. Okay, so A, well, before we can find the A, we have to find x. So x squared plus 6 squared is equal to 10 squared. So x squared plus 36 is equal to 100. So therefore, x squared equal to 64. You subtract 36 from both sides, and therefore x is equal to 8. X is the square root of 64. We got 8. So now we know that this other leg is 8. You want to call it the base or the height, it doesn't matter. Okay? So now we can find the area. And we're going to use A for area. That works. Is equal to 1/2 base times height. It's always good to quote the formula, then plug in your numbers, then simplify. So this is going to be equal to 1/2 times 6 times 8. And then of course, 1/2 of 6 is 3. 3 times 8 is. In this case, since you are not given the units, in this case, you put 24 square units. Okay, because it's area, so it's going to be square units. And that's how you do that question. Okay. Let's look at another one. Okay, this is interesting. Suppose this was, say, 26. No, let's not use 26. Should we use 26? Okay, let's try a different number. Suppose that was, say, let's try 17. Okay, and let's say this was, say, 8. Because we have not done trigonometry yet, I'm being very careful with what type of questions I do now, because as we do trigonometry, there become a lot more options available to us. Okay, so let's pretend that that's 8. Okay. So our triangle is this. So obviously, as you look at it, the shaded triangle is not a right triangle. It's not a right triangle, but the formula says it's 1/2 the base times the height. So if this was given to us as, say, 20, from here to here is 20. From here to here is 17. And if we were to drop a perpendicular from here to the horizontal and form a right triangle, okay, then we could actually find the height of our triangle. So this is really pushing it to another level now. So if you can find this, then that's actually your height, and your base is from here to here, because this is not part of your triangle. This is not part of your triangle. Your triangle stops right here. So this is your base, 20 is your base, but from here to here is 28, okay? But the importance of this is that we can actually find the height. How high is the triangle from the base? How high is it? This point is how high. If I can find that number, boom, I got myself the area. So we just did the Pythagorean theorem. If this is 8 and this is 17, we can find h. So let's go, let's set it up. 8 squared plus h squared is equal to 17 squared. Leg squared plus leg squared, hypotenuse squared. So what is 8 squared? 8 squared is 64 plus 8 squared is equal to 289. 17 squared is 289. Subtract 64 from 289, we end up with h squared equal to 225. Okay? And if 8 squared is 225, then h has to be the square root of 225. And it so happened that the square root of 225 is 15. So now we have the base, we have the height, we can find the area. So area is equal to 1/2 times base times height. And in this case, it's going to be 1/2 times the base is 20 times the height is 15. And that works out to be 1/2 of 20 is 10. 10 times 15 is 150 square units. Now you're going to say to me, wait a minute, you told me that you can only use 1/2 base times height if it's a right triangle. Well, yes, now we have created a right triangle as an extension in order to be able to find the height. That is really the catch right there. Without the height, we cannot proceed, okay? Now that you have the height, you can multiply, you can apply the formula base times height times 1/2. And that's what that works out to be, okay? How cool is that? To me, that's pretty cool. So let's try another example. Let's try another one. Okay. I'm trying to get numbers that will work. Okay. Suppose this is whenever you have a shape and you have these two symbols identical, you see that the shape, the two sides are the same length or they're congruent. We're not going to spend a lot of time on that. They're the same, but for now, I'll just label them as identical. So if this was 16, and this was 16, and so this was 18. Okay? Find the area. Let's call this A, B, C. Triangle A, B, C. So find the area of triangle A, B, C. So I'm squeezing in some notation on you. You see the triangle ABC. Triangle ABC. So A, B, and C are the vertices. So this is side AB, this is side AC, this is side BC. So this, with the two sides being the same length, it has a name. This is called an isosceles triangle. So if you drop a perpendicular, if it was drawn properly, it would actually bisect the triangle. In other words, it will divide it into two equal halves. Okay, so this will be identical to this. So if it is identical, then it means that this is 9, and this also is going to be 9. And then, of course, if you drop a perpendicular, then you now have a right triangle. So far, so good? Okay. So, if I am able to find this height, if I'm able to find this height, and I know that this base from here to here is 9, because it's a half of BC, it's 9. So if I use Pythagorean Theorem and find h, then I can find the area of the half of the triangle, and then to find the area of the entire triangle, I just double it. Yes? Okay. So the first line of business is to find the height. And again, we go into Pythagorean Theorem. We have h squared plus 9 squared equal to 16 squared. So h squared plus 81 equals to 256. So h squared is equal to 256, take away 81, gives me 5, and I think that's 17. Yes? Okay, so therefore h is the square root of 175, which is going to be approximately equal to 169 is 13 squared. So it's going to be 13 point something. Approximately 13 point what? So let's go and try and find out. So the square root of 175 is equal to, oh, I need to turn it on for it to work. Square root of 175 is equal to approximately 13.23. Approximately 13.23. Okay? So now we have the height, we have the base, so now we can find the area. So area, triangle A, BC is going to be equal to 2 times a half times the base, which is 9, times the height, which is 13.23. So that's equal to 2 times a half is 1. So then it's going to be just 9 times that. So 9 3 is 27, 9 2 is 18, 9 2 20, 9 3 is 27, 29, 9 1 is 9, and 2 11. So it's 119.07 squared. So look how easy we started out. Just simply a squared plus b squared equals c squared. And then look how we transitioned until now we're solving triangles, finding the area of triangles that are more complicated, but we're using what is already in our toolbox. Again, that is what we do. We build up, start basic, and then we add the floors. I hope you found this interesting. I think we have had a good session, and this is only to whet your appetite. Come next week, we're going to transition into a few more things having to do with shapes, okay? And before long, I'm going to introduce you to trigonometry. Can't wait. But I think next week I'm going to spend some time. Maybe we should just go straight ahead into trigonometry. Yes, I think we'll do that. Sine, cosine, and tangent. Yes, sine, cosine, and tangent. We're not going to go complicated, but we're going to go into some principles that are directly related to finding area and finding distance. I think it's an appropriate transition from here into going to the basic trig ratios, sine, cosine, and tangent. So please don't miss. And as you know, if you miss a session, you can search and you'll find these sessions, Learning Together. If you do a search on YouTube for Desmond Dunkley on YouTube, you will see the Brosis Foundation Learning Together seminars and workshops, okay? And you'll also, if you search on YouTube, Dawn Dawes, you'll also get all the English presentation. So there's nothing to worry about. These are now saved and you can watch them over and over and over. The quickest way to get all the tutorial is to go onto Google and do a search, use my name, Desmond Dunkley, and you'll see all the Brosis Learning Together sessions. And if you use Dawn Dawes, you'll also see all the English workshops. Okay? Thank you so much for joining us. And on behalf of the Rusty's Brosis Foundation, we say thank you. And we encourage you to visit our website, Rusty's Brosis Foundation, and you'll be amazed. You might just find something that will interest you. Okay? Enjoy the rest of your day and see you on Tuesday for our next session. Thank you.